Is that the cause? And we'll be looking at oxidation number in this video. You are not unfamiliar with oxidation number, but it's very important concepts in redox reaction. And what is oxidation number? It's an electrical charge that an element or a substance appear to have in a molecule according to a set of rules. We call that oxidation number. There are some rules around oxidation number, and when you apply that rule, you can determine the electrical charge of any substance in a molecule. You call that electrical charge oxidation number. Where do we apply oxidation number? So oxidation number is applied in various life of chemistry. For example, we use oxidation number in the IUPAC nomenclature of inorganic compound. When you hear about carbon 4 oxide, sulfur 6 oxide, those numbers are actually oxidation numbers, and it depicts that it's an IUPAC nomenclature. So when you hear about tetrazomanganate 7 ion, that 7 there is oxidation number. So it is basically used in naming inorganic compound according to the IUPAC convention. Number 2, it is used for balancing redox equation. You can use it to balance ionic equation. Then number 3, you can use the concept of oxidation number to determine whether a species has been oxidized or reduced in a redox reaction. You know that one of the definitions for oxidation and reduction is that there will be a change in oxidation number. So you can use it to know if a reaction is actually an oxidation reaction or a reduction reaction. What are the rules for naming or for determining oxidation number? I'll just brush through it because you're already familiar with this rule. Number 1, any element in their uncombined state is 0. Oxygen, when it is uncombined, is 0. Hydrogen, when it is uncombined, is 0. Sulfur, when it's uncombined, is 0. When an element is in a free state, not joined to another element, not in a molecule or any other compound like that, the oxidation number of that element is 0. Now, oxidation number of hydrogen, anywhere you see hydrogen in a molecule or a compound that is not existing free as H2, hydrogen is always +1. But if it is a compound that contains hydrogen and metal, you call it metallic hydride, and hydrogen will be -1 in that case. What do I mean by metallic hydride? For example, sodium hydride is a metallic hydride. So hydrogen is -1 here. Look at magnesium hydride. Hydrogen too will be -1 here. There's a compound used in organic chemistry for reduction. The compound is LiAlH4. That is lithium tetrahydroaluminate 3. Lithium tetrahydroaluminate 3. The hydrogen here is -1 because it's a compound of hydrogen and metal. The same thing also, NaBH4 is also a reducing agent in organic chemistry. Is sodium tetrahydroborate 3. It's also an hydride. As from the name hydrido, so you know that is an hydride. So hydrogen there is -1. But any other compound that hydrogen is not reacting with metal or is not forming a compound with metal, its oxidation number must be +1. Then wherever you see oxygen is -2. So whenever you see oxygen, the oxidation number is -2, except in peroxide. In peroxide, oxygen is -1. Of course, you know peroxide. Peroxide are compounds that have one more oxygen than a normal oxide. Let me show you an example. The formula for sodium oxide is Na2O. That's sodium oxide. So as a peroxide, it will have one more oxygen, that will be Na2O2. That's sodium peroxide. So in this compound, oxygen is -1, but in Na2O, oxygen is -2, because Na2O is a normal oxide. But when it's a peroxide, oxygen becomes -1. Look at another one. Calcium oxide is CaO. Of course, you know it will be CaO because valency is 2. So you cancel out. So it will be CaO. That's calcium oxide, a normal oxide of calcium. But when the oxygen increases by 1, it becomes a calcium peroxide. So the oxygen there is -1. So whatever you are having a -1, -1 oxygen number of oxygen is a sign that the compound is a peroxide. Now, the oxygen number of halogen is -1, and let me chip this in. Halogen is always -1, and elements in group 1 are always +1. Elements in group 2 are always +2. Elements in group 3 are +3. So in case you see them in oxidation state and they ask you to in a compound and have to find the oxidation state of any other element, for example, when you see NaCl, the Na here is in group 1, so it's with +1 state. Or say you have Na2CO3, the Na here is +1 because it's in group 1. So you can easily know the group of an element by doing the configuration. Now, when element forms a compound, the sum of the oxidation number is always equal to 0. We apply that later. And when element forms a radical are polyatomic ions, that is, ions formed by 2 or more elements. You call them radicals. When they combine together to react as a single unit, they are radicals. So radicals usually contains charges. So the elements there, the sum of their oxidation number is always equal to the size and sign of their charge. Let me give you example on what I'm talking about. If you have PO4 2-, for example, if you have a PO4 3-, for example, the meaning is that when you add up the oxidation number of phosphorus and oxygen together, it must give you -3. So the sign and size of the charge on a radical is usually what you will get when you add up the oxidation number. But for a normal compound, you get 0 because there's no charge on it. In simple ion, the oxidation number is always equal to the sign and size of that simple ion. Simple ions are ions formed from one element, like copper 2+ now. The oxidation number of copper 2+ is +2 because it's a simple ion. N3-, you know that's a simple ion to form from only nitrogen. Then the oxidation number will be -3. S2-, the oxidation number will be -2. So it's always equal to the sign, that's minus, and size, that's 2, of the charge. So let's look at some example in this place. So I want to look at the oxidation number of sulfur in H2SO4. So don't forget, what I need to do is this. H2SO4, that's a compound. So that means the sum of the oxidation number is supposed to be equal to 0. So I'll be having H2SO4, everything must be equal to 0 because it's a compound not carrying a charge. So from the rule, wherever you see hydrogen should be +1, except in hydride, and it's not an hydride. And whenever you see oxygen should be -2. So here now for hydrogen, there's H2. That means 2 times +1. Now 2 times +1 because hydrogen is occurring twice, so that will be 2 times plus 1. Now we are looking for state of sulfur, so you write that sulfur as S since you don't know the states, plus, now this oxygen. Now we know that oxygen is -2, so that's -2, and of course it's appearing 4 times, so that's supposed to be 4 times -2, 4 times -2, everything gives us 0. Now 2 times plus 1 is 2, plus sulfur, 4 times -2 is -8, equals 0. So when you do your arithmetic, your sulfur will be plus 8 minus 2, that will be plus 6. So sulfur now, oxidation number is plus 6. So that will be plus 6. The sign is very important. In oxidation number, you must put the plus or minus. So I will not write only 6, but I will write plus 6, because oxidation number must carry a charge. Here in this case is plus. So the name of this compound now will be tetraoxosulfate 6 acid. So it's an acid because there's hydrogen beginning the compound and SO2 minus radical. So SO2 minus is tetraoxosulfate 6 ion. So with hydrogen at the back, it becomes tetraoxosulfate 6 acid. Let's see another example of oxidation number. So we are looking for the oxidation number of Mn in KMnO4. Again, this is a compound, not an acid now, but a neutral compound. So we are having KMnO4. So the K here is plus 1. You know why I know it is plus 1? Because it's in group 1. Potassium is number 19 and is a 2881. So it's in group 1. So the oxidation number is plus 1. So appearing only once, plus 1, plus Mn, plus, because I don't know what Mn stands for, we are looking for Mn, equals to, so plus O4, that's 4 times -2. Everything must be equal to 0 because it's a neutral compound. So now we are having plus 1 plus Mn plus 4 times -2 equals 0. So that will be 1 plus Mn minus 8 equals 0. So when you do your mathematics very well, your Mn will be equals to plus 8 minus 1. That will be plus 7. So this compound now becomes potassium tetraoxomanganate 7. So plus 7, put the plus, is very important. So the compound becomes potassium MnO4 is tetraoxomanganate 7 ion. So you write it as tetraoxomanganate 7 VII. So that's how you use oxidation number to name compound. Let's see one more example before we do exercise. So calculate the oxidation number of Cr in Cr2O7 minus. Now this is a radical. How do I know there's a radical? It carries a charge. So when it carries a charge and it's from more than one element, it's a radical. So radicals are atoms of different elements that come together and react as a single unit. So what do? We are looking for Cr, right? So Cr is not known, but it's occurring twice. So we're having 2 Cr. 2 is there because it's occurring twice. Plus oxygen is 7 times, so that's 7 times -2. Everything will be equals to -2. You know, -2 because that's the charge it's carrying. I told you before that in a radical, the summation of the oxidation number of the element inside is equal to the size and sign of the charge of that radical. So now we have 2Cr minus 14 equals to minus 2. So 2Cr equals to minus 2 plus 14. So 2Cr is equals to plus 12. So and when you do the calculation very well, Cr will be equals to plus 6. So your Cr now becomes plus 6. Plus 6. So that's the oxidation number of chromium in this compound. So the compound become heptaoxo because hepta is 7 oxygen. 7 is hepta. So we are having heptaoxo. Chromium is appearing twice, so you call it dichromate. Now our answer is plus 6, so 6 Vi. So the name is heptaoxo dichromate 6 ion. So it's a radical, so you call it an ion. It's a dichromate 6 ion. So we have one more example before we go, and in this example we are looking for the oxidation number of sulfur. Sorry, not sulfur. Now change it to carbon, please. Carbon in Na2CO3. Now what do we do? Sodium is a known element, is in group 1. So the number is plus 1 times 2 plus carbon plus oxygen is also known, is minus 2, but occurring 3 times. So 3 times minus 2 equals 0. Equals 0 because it's a normal compound, it's a neutral compound. So I'm having a 2 plus carbon minus 6 equals 0. Minus 6 is from 3 times 2. So carbon will now become plus 6 minus 2. Carbon becomes plus 4. So the carbon in this compound is plus 4. So the compound becomes sodium trioxocarbonate 4. Is a compound, is a normal source. So just sodium trioxocarbonate 4. Alright, so example 5, similar thing. We are looking for P, and hydrogen is already known. So that will be 2 hydrogen, that's 2 plus 1, because 2 times plus 1, because H is plus 1, plus P that we don't know. Now oxygen is occurring 4 times, that's 4 times minus 2 equals to minus 1 is the charge because it's PO4 minus. So you can see the minus on top, minus 1. So 2 times plus 1 is 2 plus P. 2 plus P minus 8 equals to minus 1. So P becomes minus 8 plus 8 rather minus 1 minus 2. So P becomes plus 5. So the name of this radical becomes dihydrogen. It's a radical because there's a charge on it. Dihydrogen tetraoxophosphate. P is phosphorus, so it becomes a phosphate in a radical. Phosphate 5 ion. So that's the name of that radical. So let's look at these exercises. So try these exercises. Calculate the oxidation number of the central element in the following. I have deliberately changed the color of the central element. For example, in Na2S2O3, the central element is sulfur. In H2SO3, the central element is sulfur. In H3PO4, it is phosphorus. In NaClO is chlorine. In KiO3 is iodine. In HClO4 is chlorine. So find the oxidation number of the central element in this place. That's exercise 2. You can pause the video to write it. Then next, find the oxidation number of. Okay, now it should not be central, though it's central element in the ion. And the same way I did for exercise 2, I've changed the color of that central element so that you will know. For example, for A now it is S, for B is X, for C it is a Cr, for D is Mn, for E is N, for F is CO3. And you can observe that all of them are radicals. So try naming these radicals without except B, that the X is an hypothetical alphabet. Then this exercise 5, which is supposed to be exercise 4, so but leave it as exercise 5 and do it like that. They are complex ions. The only one that is not complex ion, not complex compound there is option C. Question C is a double salt, where you see ammonium ion and chromium ion and SO42 minus. So C is a double salt. This one is a double salt, but the others are complex salt. This is a complex salt, complex salt. This is a complex ion, complex ion. So try your luck and on this question. But let me give you hint. When you are dealing with double salt or complex ion, having the knowledge of the oxidation number of those radicals are important. For example, OH is OH minus. So anywhere I see OH, I just put -1 there and go my way. CN is CN minus. Anywhere I see CN, I put -1 there, I go my way. SO4 is SO42 minus. So anywhere I see SO4 in a salt, I just put -2 there as the oxidation number of all the SO4. Then I will get my answer. So when you see a normal compound inside bracket like we see in H2O, in this kind of complex ion, they always have a oxidation number of 0. But if you don't know, just do it normally, you will still get your answer. NH4 is a radical, it carries plus. So anywhere you see NH4, it should be +1 that will be present there. And H2O, because I told you it's a neutral compound, the oxidation number will just be 0. So take note of that and use that hint to attempt or tackle exercise 5. So I just want to give you okay, we'll do that one, so we'll do this one later. So let's stop here in this video and we'll continue the topic from next video. Thank you.